Right now, somewhere out in the open air, a single bee is making a decision that could decide whether you walk away untouched or end up surrounded by hundreds of her sisters, all stinging at once. And here's the strange part. Almost everything you've ever been told about surviving that moment is wrong. Running in zigzags? Wrong. Diving into a lake or a pool to escape? That might be the worst decision you could possibly make, because the thing that actually saves you when a swarm turns hostile has almost nothing to do with outrunning one insect. It has everything to do with chemistry, and alarm systems so fast and so devastating that scientists are still trying to fully understand how it spreads. I've spent years getting close enough to active hives to watch that alarm trigger in real time, close enough to hear the pitch of the hum change right before everything goes wrong. I'm Nathan Wild, and today we're stepping into one of the most misunderstood defense systems in the natural world. Because here's what most people don't realize. A bee chasing you isn't really an attack. It's a message, and that message is built to travel. To understand why, we have to start small, smaller than the bee herself. Tucked at the tip of her abdomen is a stinger lined with tiny backward-facing barbs, almost like a fishhook. In a honeybee, that barb design means the stinger doesn't pull free easily. When she stings you, it often stays embedded in your skin, tearing away from her body in the process. It sounds brutal, and it is. For her, a worker honeybee that delivers a sting like this will die shortly after. She isn't fighting for herself. She's sacrificing herself for the colony. But that sacrifice does something extraordinary.
As the stinger tears free, it leaves behind more than venom. It releases a chemical signal called isopentyl acetate, an alarm pheromone that smells to other bees almost exactly like a ripe banana. The moment that scent hits the air, nearby bees don't think, they react. They home in on the source, ready to sting the same target. One sting can become 5, 5 can become 50, and suddenly you're not dealing with a single insect anymore. You're dealing with a chemical broadcast that the entire colony is built to obey instantly. Personally, I find that almost unsettling in its efficiency. A creature with a brain smaller than a grain of rice has a communication system precise enough to mobilize an entire defensive force in seconds using nothing but scent. Before we go further into how this defense escalates and what you should actually do when it does, I want to invite you to come along on more of these expeditions with me. Every week, I'm crawling through leaf litter, standing a little too close to hives, and chasing down the science behind the creatures most people walk straight past. If that sounds like your kind of adventure, this is a good moment to subscribe, because what we're about to uncover next is one of the most dangerous chapters in the story of bees, and humanity's accidental role in writing it. In the 1950s, researchers in Brazil were trying to solve a practical problem. European honeybees, brought over generations earlier, struggled in the South American climate. So scientists imported a subspecies from East Africa, bees known for being far more productive in tropical conditions. The plan was careful: controlled breeding, contained populations, a gradual introduction. Then, in 1957, a handful of African queens escaped containment.
What followed wasn't just biology. It was one of the most studied insect events of the 20th century. The African bees interbred with local European honeybee populations, and the resulting hybrid, what we now call the Africanized honeybee, inherited a defensive intensity unlike anything seen before in managed bee populations. Where a European honeybee might send out a handful of defenders and give up the chase within 10 or 20 meters, an Africanized colony can mobilize hundreds of bees and pursue a perceived threat for several hundred meters, sometimes continuing the chase for a quarter of a mile or more. That number still genuinely surprises me every time I say it. A quarter of a mile for an insect that weighs less than a paperclip. And here's the part that fascinates entomologists most. It isn't that Africanized bees are more venomous. Sting for sting, the venom is nearly identical to that of a European honeybee. The danger comes purely from numbers, and from how quickly, how broadly, and for how long that alarm pheromone keeps recruiting reinforcements. Toxicologist Justin Schmidt, who spent decades cataloging insect stings on what's now famously known as the Schmidt Sting Pain Index, has pointed out again and again that it isn't the chemistry of a single sting that makes these bees dangerous, it's the sheer scale of the response. There's still genuine scientific debate about why the defensive radius varies so dramatically between colonies. Some hives barely react to a disturbance 50 meters away, while others within the same region will pursue someone who wasn't even close to the nest.
Researchers like Thomas Seeley, who has spent his career studying collective decision-making in honeybee colonies, has shown that bees don't operate on individual judgment at all. They operate on threshold response, a kind of decentralized democracy where enough alarm signal triggers a colony-wide action, almost like a vote that happens in under a second. So, if the defense really is a chemical chain reaction rather than a chase by one angry insect, what does that mean for the moment you're actually standing there, hearing that pitch change, watching the first few bees peel off toward you? This is where most of the common advice quietly falls apart. The instinct to dive into water seems logical. Bees can't follow you underwater, right? But here's the unsettling truth researchers have documented in real incidents. Bees will simply wait. They hover above the surface, and the moment you resurface for air, they're still there. People have been stung repeatedly trying to use water as an escape, sometimes for much longer than if they'd simply kept moving away on land. The advice to run in a zigzag pattern, the way you might evade a dog, also misses how bees actually track you. They aren't relying primarily on vision to chase a fast-moving, erratically dodging target. They're following the alarm pheromone trail and orienting toward movement and dark contrasting shapes, particularly around the head and face. Zigzagging doesn't confuse that system, it just slows you down while you're still inside the danger zone. So what actually works? The real answer, confirmed by entomologists and emergency responders who've studied Africanized bee incidents for decades, is almost disappointingly simple. Run. Not zigzag, not freeze, not swat.
Run in a straight line, as fast as you can, toward the nearest enclosed shelter, a car, a building, anything with walls and a door you can close behind you. Pull your shirt up over your nose and mouth as you go, because bees target the face, and protecting your airway matters more than protecting your arms. Don't swing your arms to bat them away. Crushing a bee against your skin can trigger the release of even more alarm pheromone right at the point of contact, which is exactly the opposite of what you want. And if you do get stung, the way you remove the stinger matters more than people think. Pinching it between two fingers to pull it out can actually squeeze the venom sac and push more venom into the skin. Scraping it out sideways with a fingernail, a card, anything flat, removes it cleanly without that extra dose. Every time I walk through this sequence with people, I'm struck by how counterintuitive good advice can be. The instincts that feel protective, diving for water, swatting wildly, darting unpredictably, are often the exact behaviors that keep you in danger longer. Sometimes the bravest thing isn't fighting back, it's simply leaving, calmly and directly, and trusting that the threat was never really about you as an individual. It was about a chemical signal doing exactly what millions of years of evolution built it to do. And that, to me, is the part worth sitting with after the science fades into the background. We tend to think of a swarm as chaos, as anger, as aggression. But what we're really watching is one of the most disciplined communication systems in the natural world, operating at a scale and speed our own bodies were never built to outthink. Respecting that system, rather than fighting it, is what actually keeps people safe.
If colonies that small can coordinate a defense that precise, imagine what happens when insects cooperate not to defend, but to build, to hunt, or to think collectively as one enormous mind. That's exactly where our next expedition is heading, into the world of ants, and the unsettling intelligence of a colony that behaves less like a group of individuals and more like a single living brain spread across thousands of bodies. I'll see you there.